Hi, everybody. Today we're here again for the next RHEA Talk. I think it's already the 14th RHEA Talk in this type of environment and in this setup. Today, I hope you know what the topic is. It's digital twins for a more secure and sustainable world. I will allow the people that are still joining for another minute to join before we really kick off. In the meantime, I also want to already make some public relations for the 15th RHEA Talk, which will happen still this year. I think it will be early December, where we will also, I think we will talk about, if I'm not mistaken, one of the topics will be new space economy. So that's it's the 15th RHEA Talk, early September. So keep an eye on the social media to see whether the announcements pop up, and then you can register the way you've registered earlier today. So I think we're a minute in. I don't know how many people have been joining at this moment. To be honest, I don't know how to see that even. So I think we're good. I see there we have 42 participants that join on the bottom of my screen. So that's good. Thank you, everybody. Again, 14th RHEA Talk. Digital twins for a more sustainable and secure world. I am here with me with a very nice panel who I will introduce, and after which I will give them some time to explain to all of us what they're doing on those topics of digital twin, after which we will be able to ask some questions after we have had all the panel participants have a talk. So first of all, we have Michiel Schick from the DestinE System Manager of EUMETSAT. He has been with EUMETSAT for 20 years, if I understood correctly. And he's now the System Manager of the Digital Solution and SAF Division at EUMETSAT. I'm sure he will explain us afterwards what this all means. He's very used also to the space industry because he has been working for a decade at ESOC, being responsible for the generic mission control system of ESA satellites, in which RHEA also has contributed, if I'm not mistaken. So next to Michiel, we have Jörn Hoffman, who's working at the Destination Earth Application Partnership Lead at the ECMWF. This is the most difficult acronym to remember, but also there, I think Jörn will clearly explain what it stands for and what they are doing to support the progression on digital twins. Next to that, we have Doug Wiemer. He's the CTO Cyber from the RHEA Group. And he's responsible for management, development, and delivery of our cybersecurity-related services to the governments, agencies, and industries. In the end, Doug also has to guard and create and define the roadmap of cyber within the RHEA Group. Last but not least, we have Michiel Vullings from ATG. He's the Manager of Innovation and External Relations. After 2017, so it's not that long ago, he started actually at ATG with the managing the digital services and products. So it's quite a new activity, mainly with what is called the Media Lab and their virtual lab that they have, and in which they're quite successful. And now in parallel, he's actually doing innovation management and management of the SCN Avatar, which he will explain also a bit more later today. So having done that, myself, I'm Arne, I'm the CTO of the RHEA Group, and by that we have introduced everybody. So here I would like to give the word to Michiel. Michiel, if you could explain us a bit what EUMETSAT is doing for DestinE and also what DestinE is.
Yes, good afternoon, everybody. I present Destination Earth. So an introduction, what it is. Destination Earth is addressing a highly accurate digital model of the Earth. So we have a model component in there in the project, and we have the physical observation and the physical data. So some of the goals that are trying to be addressed is to create and test kind of what-if scenarios to integrate and impact sector applications for more sustainable developments. Also, it's in support to a near real-time decision making and to get beyond current complex systems designed only for expert use. And so the Destination Earth initiative, the owner is the European Commission, and it's under the Digital Europe program. And so it involves EU industry, and it also encompasses or incorporates activities developed under Horizon Europe. And the Destination Earth is implemented by 3 entrusted entities. So it was earlier introduced. I have my colleague here from ECMWF. So it's ECMWF, which is there, and they're responsible for the component of the digital twins itself. And Jörn will explain that in more detail later on. There's also ESA involved. ESA is implementing the user-facing side. So they implement services, core services and advanced services. And EUMETSAT, where I'm involved with, is providing the Destination Earth data lake component. And I will drill down in a second into this component to give you a bit more insight. Destination Earth itself has been started or kicked off in 2022 and is a long-term activity. It goes into up to 2030. And so it's done or implemented in various phases. So in the moment, we have not yet a system ready for users to be onboarded, but we are about to engage with users and implement use cases to demonstrate some of the things that we have already developed. And we start with a pre-operational phase from June 24. And from there on, it evolves further in phases. So as a general concept, what DestinE will offer to users, experts can come, policymakers, decision makers. They will come through the ESA entry point, through the user-facing portal, and they can find their data. And data can be composed out of digital model output data. Jörn will later on tell some more details. We have initially 2 digital twins. One is the extreme weather and geohazard twin, and also a climate adaptation twin. They provide easy access to federated data spaces, and people can use that in a form of collaborative research environments and can use advanced services to develop answers for the kind of what-if questions. I will now drill down in the Destination Earth data lake component. The data lake itself is a self-standing component built from geographically distributed physical elements. We have some kind of edges there which are sitting close to the data, close to HPC computers where a massive amount of data is produced. And we will have as well a central site where we will have access to federated data. The main services of the Destination Earth data lake is the discovery of the Destination Earth user-driven data portfolio. We will provide access to data, to the digital outputs, the model data, and also to federated data sources. Data can come from more than just Earth observational environments. We will federate and connect to other data spaces. So here, this is a sort of also novum, because we will incorporate and facilitate access to biodiversity, maybe health sector and or other kind of data spaces in order to combine that with model data, which comes from the 2 twins. As part of that, in the future, there may be other digital twins incorporated. So we started only with these 2 ones, and but that will evolve over time. So that concludes the brief introduction from my side. Thank you.
Thank you, Michael. So very clear to me, maybe also clear to me because I'm aware of what DestinE is about. But I think it's indeed very useful to have Jörn now explain a different part of DestinE. But Jörn, I hope you could also elaborate a bit more wider than only DestinE, and just to explain us also a bit why now these digital twins are suddenly popping up. Maybe it has to do with the computing power, maybe it has to do with other reasons which were mentioned by Michiel as well. that we just have the competence now better. We have the sensors, etc. So if you could give us a view on that, that would be very, very welcome. Thank you.
Yeah, thank you, Arne, and I'm happy to be here. Good afternoon to everybody. So following up on what Michael is doing, what has explained, in the context of Destination Earth, the role of ECMWF, and to resolve that miracle, it's the European Center for Medium Range Weather Forecasts. So we've been doing weather predictions, the medium range, that is up to 14 days into the future for 5 decades now, and are also a key partner of the European Union and other European entities in the Copernicus program, doing the climate and the atmospheric services there. So in Destination Earth, we are building the 2 digital twins on the 2 topics, one on climate adaptation support and one on extreme weather impacts. And I'll go into a little bit more detail later on. But I'd first like to start by explaining a little more what we understand as a digital twin in the context of Destination Earth, because there are different definitions that are around. For us, that really encompasses 3 elements. The first one is investing in improved modeling. So in DestinE, that is running these Earth system models at a much higher resolution than they previously were operated in. Climate models have typically been run at probably 50 to 100 kilometers or even coarser spatial resolution. And then up until the end of the next century in 2100, something like that. Now in Destination Earth, we're looking at 5 to maximum of 10 kilometer spatial resolution, so much finer detail. And in the extreme weather case, global models today run at maybe 9 kilometers resolution. That's our operational model. And in Destination Earth, we're looking at few kilometers, and in the European case, even sub-kilometer resolutions. Why is resolution important here? Because some of these physical processes that happen and that really determine the Earth system, eddies in the ocean or in the atmosphere, especially when there's topography around, are poorly represented in these coarser models. There are a lot of tricks that these models employ to really cover that anyways through parameterization, but that's always imperfect and introduces biases and errors that then need to be corrected and may actually lead to wrong forecasts. So that's one domain where we're investing in making these models better and more accurate, really, for more adequate for the task at hand. The second domain that we're investing in, that makes it a digital twin, is really going one step further beyond merely simulating the Earth system behavior, but really going into the impact sectors. So where decisions are taken, that could be agriculture, that could be energy, renewable energy production, that could be disaster response activities, really. So impact of this behavior of the physical system for human anthropogenic systems. That's the other domain, and making that more interrelated is where this becomes a decision support tool. So it's really an information system. And interactivity is the third domain. So allowing users, and Michael hinted at that, allowing users to really interact with the system, come with their questions, what we call what-if scenarios, to really understand how the system will behave under different scenarios, responding to decisions that are in these impact sectors or even in mitigation or adaptation scenarios. Why have we picked those 2 topics, extreme weather and climate adaptation? Well, one, it's because we do have mature modeling systems that we can integrate into the digital twins, because that's, of course, one of the core components, but also because of their economic relevance. I mean, it's no surprise and no secret that the financial and economic, and also in terms of lives lost impact of these events is dramatic, and really singles out those 2 domains for prioritizing them in this context. You asked, Arne, why now? And it really does come down to the synergy of rapid development in computational power. We do now have the Euro HPC systems being built across Europe. that are really what makes makes this vision even feasible. We've been pursuing these scalability elements in innovations and developments for a number of years now, but really only now do we have the computational power to realistically run these large-scale, high-resolution numerical Earth system models globally at the scale where we need to run them. And it's still a development effort to make these codes run efficiently on these new machines. And that's also, of course, a lot of what we've been doing in the development phase. But also at the same time, as you know, artificial intelligence developments are really picking up, and you know, we are standing to benefit from these developments in our developments. So how will this be used? And I'll see you popping up. So yeah, I need to come to a close. But you know, the vision really is that, for example, weather services or environmental agencies or other expert institutions supporting policymakers will be able to run their own simulations and ask their questions to the system, and then inform decision making at the political level in terms of making these policies, but also in terms of implementing these policies. And I'll stop here.
Thanks, Jörn. And I'm happy that both Michiel and you have mentioned the user, because that for me is also an important part. And what I understand is that the usage will be expanded not only so out of the pure expert user point of view, so that also normal people can potentially use it, and mainly to make decisions. And this touches on another thing, which I will use to introduce Doug, is that we will have the opportunity to use these digital twins as forecast machines. Yeah, because what we want to do is to model our environment, to not know, to partially know what happened in the past, to better understand, but also to forecast, to make decisions for a better future. So, Doug, from your point of view, and this is mainly a cybersecurity one and the space one, how do you see this evolvement?
Yeah, thanks very much, Arne, and thanks to everyone, and welcome to the talk today. It's my pleasure to be here. Yeah, so maybe just touching a little bit on what Jörn was just saying, that there are different interpretations, different definitions of what is a digital twin. And so in the context of cybersecurity, at least the context of cybersecurity, the way that RHEA looks at that, one of the main differences perhaps, or the unique aspects of a cybersecurity-oriented digital twin is really that it is much more emulation-based than model-based. And so what we mean by that is that we'll actually look at the evolution of a cyber range, and some of you may be familiar with a cyber range and what a cyber range is and does already. But effectively, a cyber range is a virtualization environment in which we can actually run real versions of operational systems. And so that's why we refer to it much more as an emulation. And so in our case, it's much less model-based, and it's emulated through the running of these virtual machines, and also the interconnections of all of them. And so the means by which the complex systems can be emulated allows us to model dangerous things in a safe environment. Now, in some cases, models or simulators may be necessary if there are aspects, for example, of a space system that can't actually be virtualized. Then we'll look to use models or simulators in those cases. But where possible, we really want to be able to have actual instantiations running versions of the operational system. And that allows for really high fidelity emulation of the space ground systems, the ground to space connections, and the space assets themselves. And as I said, this creates really a safe environment in which we want to emulate dangerous things, right? So cyber incidents, cyber events, we can really explore, as Arne, as you just said, what happened in the past, but also what can we do about them. So it allows us to really explore mitigations as well. And so why would we want to do that? What does that allow us to do and explore? First and foremost, which is fairly common already within a cyber range, is for space and cyber operator training. But then as we move from the training focus, it also allows system and component level cybersecurity tests. So, for example, to support the testing that we may see coming from the Cyber Resiliency Act, supports development of realistic and tested and proven playbooks. And so this is important. The emulation environment, the digital twin, allows us to take real data and use that real data, so real situations, and explore those playbooks and prove out those playbooks for how we're going to respond. And then ongoing system level security accreditation and authorization. Of course, as things change, as we want to update systems, as we want systems to be able to respond to new and emerging threats, very often the operational environment needs to change, and we can explore those changes within the digital twin as well to ensure that those systems are still operating in a way that is that minimizes the risk. Some of the challenges to be overcome in the design approach, of course, there's managing the unique nature of the space domain. There are certain things like emulation of radio frequency impacts that are not, let's say, not obvious to virtualize within a scenario. And so we need to be able to manage those kinds of things. But other aspects, there's potential limitations due to the unique ground system or space assets that can't be virtualized. Maintaining coherency between the operational system and the digital twin, not only as the platforms themselves may change, but as the data that's coming and the coherency of the, let's say, the operational state of the operational system versus the twin. Other aspects, capacity needs of the digital twin, the host environment. Sometimes we need to take those very complex systems and decompose them into smaller aspects of a scenario, just to manage the capacity needs that are needed within the virtual environment. Of course, data transfer rates from the operational system to the digital twin. This touches on the coherency as well. You want to try and maintain things in as coherent a state as possible. And of course, since you're connecting to the operational system, we have to make sure that this connection is secure and that the twin itself is not going to have any impact back on the operational system, and that the twin can't be used somehow as a connection point into the operational system. And overall, we need to design for the assurance of the priority of the operational system. Very often, these are not just these cyber digital twins. We're looking not only at space, but other critical infrastructures, and all of these domains, space and other critical infrastructures, the operational system and the primacy of the operations on the operational system always needs to take priority over whatever we're doing in the digital twin. And thank you very much.
Thank you, Doug. So yeah, I think it's important to repeat a bit what Doug said in the beginning. We have different definitions. Jörn said it as well. So depending on who you talk to and depending on the industry you talk to, you have really a model that is a self-standing thing, or you have a model or an emulation that is actually linked into the real system, getting even, for example, the same data as the real system to see how it could behave when you put maybe other sensors, other cybersecurity tools in the loop. You know, so we're heavily involved in that. But in both cases, the things that Michael said, Jörn said, and Doug said, we are a user through a screen. So when we were designing this RHEA Talk, I thought, geez, I know a guy, I know some people that are moving further. We can be part of the system. So that's why I thought it was good to invite Michiel from ATG, because together with Michiel and some others, we are part of Avatar, where we want to bring virtual reality and augmented reality into our engineering and into sort of the digital twin world. So Michiel, the floor is yours. So it would be nice to hear you from that side of the spectrum.
Yeah, thanks, Arne. Yeah, indeed, I was not going to be talking about digital twins per se as such, but rather about the interface towards digital twins and towards simulations in general, really. Maybe one little step back, explaining a little bit about who I am and indeed the connection that I have with Arne and RHEA. Michiel Vullings, I'm Manager Innovation and External Relations at ATG Europe, which is an engineering services company. Been doing that for 20 years, more or less, not the managing innovation part, but working at that company. As Arne mentioned, from 2017, I've been leading the digital services and products division within the company, which is basically digital media, as you can see from behind me, making visualizations and animations for the space domain mostly, as well as virtual reality, augmented reality tools and software development, which is basically landing in a business unit called ATG Virtual Lab. In 2019, actually ATG and RHEA together came up with an idea to set up a foundation and a development center in Noordwijk to develop augmented and virtual reality tools and interfaces for the space domain at large. So not limited to a single part of space, but really for different applications. And we teamed up with two other institutes at the time, TU Delft, as well as the NLR, a Royal Dutch Aerospace Laboratory, and later also with the Radboud University, the astronomy part, to basically develop tools in all sorts of domains within, in all sorts of applications within the space domain. And we call that SCN Avatar, and SCN stands for Space Campus Noordwijk, which is where ESTEC nowadays is located. The center is a physical thing. It's 160 square meters of office space and development environment with all sorts of nice tools, headsets, machines, and everything to actually develop the interfaces that we want. And together we do on a project basis all sorts of nice projects, and that can range really from every part of the life cycle of development. So what we intend to do is we want to create interfaces, the best interface for each part of the life cycle, really. So when it's the best idea to make a 2D interface, we make a 2D interface. If we think it is something that could benefit from an immersive interface, we go for a virtual reality interface or an augmented reality interface, really depending on the use case, on the application, and trying to optimize the experience for the user. And we do that, as I mentioned, for every start of the life cycle. So it really from upstream, we start with conceptual design. We do the system level design together with RHEA, for example. We do reviewing, communication in VR. We do assembly integration and testing, both from a training perspective as well as operational. So training in VR, operational in AR. We want to tackle data coming from satellites and downstream side. So basically developing interfaces for these large data sets, which could actually also apply to the Destination Earth program to potentially get more insights into the data. Can imagine also that awareness in that case is a very interesting one. And on top of that, also in the actual operations of the satellite and of other spacecraft. So, for example, remote handling interfaces or digital twinning kind of environments for satellite operations. Maybe as an example of what we concretely are doing, which is actually, as far as I'm concerned, not the most relevant, but the most concrete example of where we aim to add value at the moment with virtual reality in terms of digital twinning, specifically for security. And in our case, that is actually more, say, physical security or safety in that sense, is we are currently doing a development, and within Avatar ATG ISIS space as an end customer, as well as the NLR from educational point of view, from their side, training point of view. We are developing a virtual reality trainer specifically aimed at assembly and integration processes of CubeSats. And the idea there is that, I mean, you can build a trainer which is purely visual in the sense that you have models and that you can actually do, specific operations which seem to resemble visually the actual operations that you do in real life. But we want to take it a bit further by really applying as much as we can a level of realism to the processes that we have in there. So we are actually modeling, which in itself sounds a bit overkill maybe, but we are actually modeling the process of screwing in screws, of bending cables in the right direction, of applying epoxy, of all these menial tasks, I would almost say, to a level that is very realistic to the user. And for us, the reason being that having it as realistic as possible creates the steepest learning curve for the person to use it, and it's also lowering the, let's say, the need for additional support from employees within the company. So it actually becomes a more and more self-standing tool as you go along. Oh, that was quick, Arne. Anyway, I'll briefly continue. What we intend to do to bring that further is, of course, as I mentioned, we want to build a trainer, but as we have a realistic environment, we want to investigate in how far we can make it to such a realistic level that we can actually apply processes in terms of artificial intelligence on these procedures that we have, to see if we can optimize the procedures and the steps that you need to take to get to an assembled system. If we manage to do that, we can actually get some sort of predictiveness within the trainer that we are developing, and we can actually have a sort of a procedural prescriber, for lack of a better word, which can then be ported to an augmented reality interface, and as such support the operator not only in the training phase but even in the operational phase as he's actually creating the assembly or doing the assembly of the CubeSat. Now, the last step in that, but that's long term, is that you can actually get to a point that you can even scan in the environment as you're doing it, and then you can feed that back into your virtual environment, repeating the loop of artificial intelligence optimization and getting into some sort of adaptive training or adaptive procedural tool that allows you to learn basically new skills in a way, new assembly skills within an immersive environment. And yeah, as the 5 minutes have passed, I'll stop talking now.
Thanks, Michiel. So I really thought it was important to have you on the panel to show that it's not just that the future might allow us to walk in these nice digital twins and to be really part of it as a human being. We all know that sometimes it's nice to see something on the screen, but then if you smell, touch, feel, hear what happens around you, it's completely different, and you might make completely different decisions as well. Just as an example, yesterday I left home and I looked at my phone on the app for the weather forecast, and it said it was going to be 23 degrees, and I said, oh man, the world is going crazy now. So I left home in my shirt, but it's in the Netherlands, so it was 12 degrees and raining. So if I would have been immersed in the digital model of the Netherlands at that time, I would have known much clearly. I could have also looked outside, to be honest. I agree with that. But anyway, thank you, gentlemen, for the chat. I have several questions already from the audience, so I will just go start at the top. That's okay. So I have a question of Ivo Reis. Ivo, you mentioned the digital twin needs to be maintained and synchronized from an operational system manually. Is there currently any movement or ambition to automate this effort? If I understand correctly, that whenever something changes in the model, you need to adjust the model, blah, 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 or you need to add models, or you need to add emulations. Maybe what Jörn said already earlier, the AI might help to come up with adjustments of the models. Is anybody in the audience, in the panel, that would like to provide an answer to that, to the automated updating of digital twins? Doug is raising his hand. I don't know. Is that for a question, or are you wanting to?
No, I'm suggesting that I may be able to give an answer, but at least from the cybersecurity perspective. So
go ahead.
Certainly from the emulations that we're doing, the digital twin very often needs to, let's say, use recorded packet traces. And that's what I think Ivo is referring to in terms of, a very manual process. But yeah, indeed, there is, we are exploring the use of automated tools to be able to have a much higher fidelity and a much more near real-time emulation, and to be able to actually have, let's say, a mimic of the operational state happening in near real time with the operational system.
Okay. Jörn, you want to add something?
Yeah, I don't think the question necessarily was targeted to me, but I think, because we haven't mentioned this specifically, I think Michael mentioned that in passing, but of course, in the digital twins for the Earth system, that's exactly what happens at the beginning. And projecting climate, of course, you cannot engage new data as you simulate because it's all in the future. But for the shorter time period, the initial conditions are very informed by a lot of data, huge data sets, including satellite, in situ, and all these different data sources that Michael mentioned, and rerunning these systems repeatedly, especially the extremes cases. The idea is really that you update this very, very frequently, so you are always up to speed and automatically taking the most recent information on the state of the system to initiate that system.
Okay, thank you. See another. Oh, yeah, Michael,
Yes,
if you want. Yeah.
Yeah, I want to add something to what Jörn said. I mean, there's of course the initialization. So I think the models, for example, like the climate adaptation twin, it will start from a given year and then propagate yearly into the future. But then, of course, ECMWF, but Jörn can explain maybe much better. They have behind, there is a sort of physical model on which the different fields are modeled, etc. And for each run, there's obviously a particular software version in place, and that one has to be maintained and updated with the best knowledge and the sort of information which is learned. But then, in parallel to this, ECMWF has put as well considerable efforts into AI/ML to have as well models being able to use. So the advancements in AI/ML, not to only have a sort of a physical model which is propagated and evolved, but they have as well a very, very good progress in the area of AI/ML to use that as well. And they have done comparisons between the two, so how close they are to each other. And I'm pretty sure there will a lot happen in the next 2 years, because the roadmap goes up to 2030. And the big thing in Destination Earth is that we are flexible for evolutions and changes. So maybe what we have today in the services, so in 10 years or 5 years, it will change over time. So we have to learn from user feedback, and we have to address evolutions based on what user really needs in order to do. And so things will change over time.
Thank you. 2 questions actually related to that. 2 questions for DestinE. One question from Jess Burford, actually for Jörn. Is there already visibility on the next digital twin, so after your climate change one and the extreme weather? And then a second related question is, when will the increased resolution of the extreme events will be available for end users?
On the first one, that's of course a programmatic question that depends also on the budgets that will be made available from the European Commission for the program in the future. And there, I can only say what we see from today. We are in active discussions with groups that have been pursuing developments on different topics on Horizon Europe funded projects, including on the digital twin of the ocean. So a dedicated ocean component. Of course, ocean is part of the Earth system model that we're also operating, but there, this is going much more into into detail and supporting specific oceanographic applications. Other ones that are being implemented is on geophysics. So tectonics, tsunamis, or neotectonics, or biodiversity. So those, I would say, are the sort of most visible front runners at the moment. But again, they're, in terms of implementing them in the future, that depends on budgetary decisions of the European Commission or European Union. On the second question, when is that available? The models are running in their test configurations today. These data will be produced from on demand from the middle of next year, middle of 2024. The discussions on accessibility of these data to the world is currently ongoing at the EU level. We are implementing a free and open data policy, but there is technical considerations and also regulatory configurations in terms of who gets who's mandated to issue warnings and the like, so that the actual timeliness and scope of the availability and who gets to actually initiate the run of the model and the like, that is still to be defined.
Okay, thank you. Now there's another question. It's a long one. It's for Doug. I don't know, Doug, whether you see those questions as well. But
I do, yeah.
Okay, so if you could answer to the question of Franco, but maybe I will give a quick summary of the question for the rest of the audience. So Franco has been involved in similar projects, trying to assess the applicability of certain architectures to create a better cybersecurity for a system. He says that it was managed according to a sort of old approach from an architectural analysis point of view, and how do we now treat that in a better way, in a more digital twin approach?
Yeah, and I think one aspect of the question there is, what causes us to move towards the digital twin, and why would we look at that? And so there's a combination of things, keeping in mind that a digital twin is, let's say, an evolution of a cyber range, and so a cyber range itself, as I mentioned in my earlier part of the talk, often treated purely from a training perspective, but the emulation allows us also to do various tests and evaluations. And so moving from, let's say, a theoretical architectural analysis into a real world analysis where we can actually run certain tests against equipment in order to prove their effectiveness. And so it gives us a much better understanding of actually how the system is going to respond. And the ideas, Franco, that you mentioned, size, complexity, criticality, these are all aspects that push us towards use of a digital twin. We have done, for example, penetration testing in critical infrastructure in the past. And of course, that's you don't want to run your penetration testing against an operational system for obvious reasons of not, as I mentioned earlier, the primacy of operations. And so we can't affect the operations of the operational system. And so let's say a few years ago, we would take the gold image of that system and launch it in a virtual machine and do tests just against that system. But that itself already puts you in a somewhat false environment that doesn't give you a real sense of what the real situation is. And so when you start to interconnect multiple systems together, right? So the complexity and the size of a complex environment, you get a better understanding of the interactions between systems during those cyber events. And so the combination of being critical infrastructure, that we can't run certain tests against operational systems, and then the complexity of the environment, the size of the environment, it moves us into this world now where we're coming into where we need to have these emulations in order to have better understanding of actually how the systems will react, not only to the attacks themselves, which evolve all the time, but also to our mitigations, to make sure that the mitigations themselves aren't going to cause problems either.
Sorry, I had to look for my cursor. Too many screens.
No problem.
Thanks, Doug. Thanks, Franco, and thanks for the audience for the questions. Let me see whether there's more. I think we ran out of questions. Well, Franco says thank you, Doug, so I think he has the answer. One more question. When we invest as companies, but very often also as institutions or like the European Commission, we also would like to see a business case. So maybe Jörn, could you elaborate a bit on how you would see the commercial interests in a DestinE or in a digital twin of whatever, how you see that commercial interest and how people could make money out of that?
Well, it's that has different facets, that question. It's an obvious one to ask, but it's not a trivial one to answer, because
that's why I pointed to you. So.
The Commission has not started Destination Earth with a primarily commercial idea in mind. Really, the primary or at least initial focus was on public good, essentially. So supporting public institutions in fulfilling their tasks in these domains: disaster risk management for environmental disasters and climate change adaptation, the challenges. But it's starting, both domains, of course, have a very clear commercial realm too. A lot of companies are investing to adapt to changing climate. Agriculture is an obvious example, transport or building infrastructure and the like. And also, of course, in the disaster space, there are a lot of business sectors that have a very strong dependence and exposure to natural disasters. The most obvious one, obviously, being the insurance sector. But there are many others. Yes, there are applications that could build on the information provided by the digital twins and downstream or integrated with. There is, I think, a very clear expectation that that will happen, but there will be also a very clear boundary, and where, in the part that is provided publicly through the funding for Destination Earth, and then the part that is provided or also developed and operate under the responsibility of the private sector. There may be a gray zone which needs to be negotiated, and here I'm very vague, and I'm aware, but I recall that we're at the end of the initial development phase, so we don't have a system yet. So this is an early time to ask this question. But I think, yes, I do think that there will be commercial use. It will be under the responsibility of the private sector, and they will gain access to DestinE information through interfaces provided by DestinE, the three interested entities, and the details of that interaction need to be defined in the future.
Yeah. That's quite interesting. If we would have an API or something that we could talk to get into the data that you have collected. So Michael, I see you would like to add something.
Yes, I think I would like to add to Jörn. So we had discussions as well in the context for trying out different use cases, and just something which came to my mind. It's only one example where this commercially could be interesting, and it's in the area of energy. And so we discussed with someone, and for the energy sector, for example, in Spain, it was in the case of Barcelona. So they would be interested to know what is actually the electricity that they need to procure for the next day. So depending on the forecast, on the precise forecast, and on the modeling of which households in Barcelona have, for example, solar arrays, and how cloudy it will be on the next day, they can predict how much additional electricity they need to buy for the next day. And as more precise this forecast is, as more efficient they can household with their expenses and don't need to buy too much. And this is only just one example. Yeah. But as Jörn said, if we initially open, so primary goal is initially for academia, research, policymakers, and so it will evolve over time to add as well the options like for the commercial. Yeah.
Thank you. One more question that I see pop up is there's a question here saying, for DestinE and DestinE, Destination Earth, what are the most significant hurdles you have faced or are currently facing on the two parts? And are they unique for DestinE, or do you think they will be happening in every or in any digital twin development?
That's a difficult question. It can be quite broad. There are challenges of both types. I think what we have invested, some of the major hurdles were really deploying and developing the next generation of these large-scale models on these very new infrastructures that were not really, not necessarily ready for operational type implementation. So negotiating that interface is definitely one of the challenges. Managing the large data volumes and interacting, that goes back to the other question that also was popping up there, is one of the challenges where we are working to make that feasible. Of the other type of challenge that we have is taking our target groups along with us, and I think that's something that may very well be more generic to digital twins. Is that, you know, at the one hand you're really developing state-of-the-art technical systems, and the other hand you're expecting the users to be able to understand the implications of that. And while there's one effort to make it easy to use, it also still requires to understand the limitations of the system that you're working with in order to take an actual decision. And that communication is only starting to happen as we're integrating more and more users, but it's definitely one of the core challenges.
Thank you. Go ahead.
Yeah, I would just like to add, I mean, there are many more challenges that we're having. Jörn addressed them quite a few, but it's of course difficult in order to assess when we had real users to anticipate. Yeah, so what resources they need, what they will consume, and to size and put the access roles and quotas in the right place and to be sized for the uptake. So in the moment, we are only sort of guessing what will happen, and we will have to react to that in the future and adapt, and maybe as well change the service portfolio that we are having. And but that is maybe as well with other big platforms, similar issues, where we had some very specific issues where as well with the negotiations of deploying the edges close to the HPC centers. So that was as well quite difficult, and we worked there very closely together with ECMWF and the HPC providers to allow us to deploy infrastructure at the HPC sites. And that starts with the footprint in the data center hall. Yeah, so to putting like, I don't know, 20 racks in their hall and being allowed to have a sort of network connection to the HPC's file system in order to get the data transferred and out, because previously it's a sort of island where it's very difficult to get data in and out, and now we want to get that out, want to get that into DestinE and make it available to users. So that is not easy, and will also be in the future not easy, because we may use as well other HPC sites.
Yeah. Thank you very much, both of you, for addressing that. I think it also answers Maria Renker's question a bit. It also depends, Maria, in my view, how large you want to approach your digital twin solution. DestinE has a very, very big challenge because they want to model the Earth, and it's wide. But if you have a smaller part to model, maybe just a system, or like in the case of Doug with their cyber range, it's a part of a cyber an IT/OT system that they would like to model. You reduce the challenges on the resources and on data, etc., big time. Now, before I close, I would like to ask Michiel, who had this question that he wanted to ask earlier, and correct me if I'm wrong. It is to see how virtual and augmented reality can be used in digital twins in the future. Is that correct, Michiel?
That is correct, but specifically towards the DestinE program. So the digital twin being the Destination Earth digital twin. Is there, let's say, where is there a link toward, or is there, first of all, a link towards any immersive environment in the opinion of my fellow panelists, or and if so, where? Let me put it that way.
Yes, is the short answer.
Okay.
It is one of the dimensions of interactivity in a way. I mean, it's not just being in front of the screen. It really does depend though on user needs and connecting the infrastructure that we're building and the data streams to the information systems that are already in use at those institutions. But we have actually, even in phase 1, invested in visualization and augmented reality developments in separate contracts, partly managed by ESA, one of them managed at ECMWF, where a competitor of yours is developing some demonstrators of how that could be done in a number of examples. Finding a few use cases there that can be demonstrated. Implementing that through VR type experiences where you immerse yourself in the data, but making that useful. There's no temperature feeling yet, Arne, sorry to say, but that is being pursued. There's no, how far that will go will really depend on our exchanges with the users, what their requirements are in that space.
And then do you see that mostly in the field of awareness creation, or is that in increasing insights in the data itself, or how do you, I mean, I don't know what the applications are, obviously, which is perfectly fine, but in what field of applications are you looking into then in that sense?
No, it could be both. I do think that that's the point that Arne was hinting at. I mean, it is allowing also not just making pretty experiences for the public to make them aware of what the changes that are happening, but really only also getting decision makers to a point. Some of them are not necessarily expert in interpreting complex plots, getting a better idea of what they're facing in order to take the decision. So it is a decision support tool, or could be. At least that's how we view it. But to be fair, it is also a domain where we still have to identify the concrete cases where we think that is most valuable.
Yeah. Okay. Thank you.
Thank you.
Arne, can I say one small thing, just as a?
If you want to greet your grandmother, then no, but it's something else. Yeah.
No, it's more, let's say, advertisement. No, not really. There is. I just wanted to mention, because there was a question regarding another VR application that someone built, and he's inviting us to have a look at that, which is not something we can do here, but just wanted to point towards a workshop at ESA on beginning of December related to AR and VR specifically for space. Have a look at that if you're interested. Just Google it somewhere, or I can send you the link on, and you can disseminate maybe, and then we can all have a look at each other's VR and AR applications.
Cool. Thanks, Michiel. So we have 2 minutes, probably 1.5. Before we end, I would like to, of course, thank the panelists. Thank you very much for the preparation to this call as well, which the RHEA Talk requires some preparation, which is always good. Thanks for providing the information. Thanks for being here. Thanks for all the people that have joined today to listen in. And just as a view to the future, I really hope that we will have a digital twin of our Earth, and that it doesn't stop with the Earth, that we will have a digital twin of everything around us as well. And that it doesn't only use models, but that we can go and do science, so that we can actually bring space into the cloud on the Earth and then do science there, instead of sending very expensive and maybe also sometimes polluting items up there to do science. So I really hope that we will get a nice digital twin of the Earth and our environment to really use, to make it better secure, but also learn from where we come from and where we're going. So thank you everybody for today, and I hope to see you all in the next one, the RHEA Talk number 15 on new and emerging space economy, if I'm not mistaken. But you will see the adverts on social media on that one. So thank you, everybody, and talk to you soon. Bye-bye.
Thank you, everyone.
Thank you. Bye-bye.
Bye-bye.